Welcome to the Electrical and Electronic Engineering Public Lecture Series. Today, we are continuing with the solar photovoltaic technology as a veritable solution to energy crisis, part 3. In this part 3, we'll be looking at battery types and wire gauges for the installation of solar energy system, the pros and cons. Your anchor person is Professor Michael C. Ndinechi. Please follow me in my public lecture series by subscribing to my YouTube channel at https://youtube.com/@NdinechiMichaelC. Like, share, and drop your comments in the comment section or reach out to me using my email addresses. You can also listen to part 1 of this lecture and part 2 also logging in my YouTube channel or using the link given. Now, solar energy systems are becoming popular, as we always say, around the world due to the growing climate change concerns and because the technology is maturing very quickly. In part 1 of this lecture, I've dealt with the benefits of using solar energy and the theory behind solar energy and photovoltaic technologies, otherwise known as the PV technologies. In part 2, I also showed you how to identify and select your solar panels to satisfy your pockets and needs. In that part 2, we also showed you how to design a moderate solar electric system and how you can do your installation and maintenance. In this part 3, we will look at the types of batteries that support solar energy system and the reasons for you to choose a particular one for what you want to do. We will also look at the wire sizes. In some cases, we call it the cable sizes that are suitable for a particular installation. We will study a table that relates the size of wire and the length for connecting your inverter, your charge controller, your batteries, and the panels. We will also look at some case studies. And finally, we will look at independent and semi-independent systems. When we say independent systems, we mean stand-alone systems. When we talk of semi-independent systems, we are talking about one that is grid supported. So let's quickly look at the types of batteries. There are 4 main types of batteries that are used for solar energy technologies, which are available for the customers to choose from. They are the lead-acid batteries, the lithium-ion batteries, the nickel-based batteries, and the flow batteries. In selecting any of the 4 batteries, you must consider your pocket first before other considerations, since each comes with a price tag and characteristics. So let's look at the first one, which is the lead acid batteries. So the best type of lead acid batteries for solar power systems are the deep cycle batteries. They are reliable and can withstand many deep discharge cycles and still bounce back to full life. Lead acid batteries can be categorized as flooded, gel, and AGM. And AGM stands for absorbent glass mat sealed batteries. When we say that these lead acid batteries can withstand so many deep cycle discharges, the meaning is that if you use the battery and it discharges to the point zero, if you charge it again, it will still be able to be fully charged. Some batteries, when you allow them discharge below certain threshold, they will never be able to charge fully again. So we say that these lead acid batteries can withstand this complete discharge for so many times before going bad. So they are best suited for standalone off-grid solar system. They are cheap, disposable, and easy to recycle. However, they require regular maintenance and have short lifespan. Lead acid batteries come in form of one, flooded batteries. The flooded batteries have caps for you to add water to them. They release gas when charged and should not be used indoors. If installed in an enclosure, a, a venting system should be used to vent out the gases, which can be explosive. The second one is the gel-sealed batteries. The gel-sealed batteries have no vents and do not release gas during charging process, like the flooded one we talked above. Venting is therefore not required and they can be used indoors. This is a very big advantage because it allows the batteries to maintain a more constant temperature and perform better. See, when the temperature rises, you lose energy in form of heat. So the sealed ones, depending on where you want to use your solar system, if you have an enclosure and you want to use it indoors, you see that it is better for you to use the gel sealed batteries. If you have where you can put them in the open, then you can use the flooded batteries because you can easily maintain them, fill them water, but they emit gases. So the choice is between you and what you have and what you want to make use of. The third one is the absorbent glass mat batteries, otherwise known as the AGM batteries. The AGM batteries are the best lead acid batteries available for solar energy system. A woven glass mat is used between the plates to hold the electrolyte. They are leak and spill proof. They do not produce gas when charging, and they have superior performance. They are of higher quality, maintain better voltage, they are slow in self-discharging, last longer, but are more expensive. So it is a trade-off between what you want and what your pocket can afford. If you are running on budget, you choose amongst these three. Then we go ahead to see another version of batteries available for you, and that is the lithium-ion batteries. So the lithium-ion batteries are best for residential solar installation because they can hold more power in a limited space. For instance, if you are installing solar in your office where you are battling with space, you see that this battery may be the best suited for you because you have limited space. They require little maintenance and have high energy density and longer lifespan. However, they are very costly. A typical sizable lithium battery can cost up to 1,500,000 Nigerian naira. The next one is the nickel cadmium batteries, otherwise known as the NICD. So these nickel cadmium batteries are not as popular as lead acid and lithium ion ones. They are popular for large scale applications because of their durability. They can operate at extremely high temperatures and require little or no maintenance. However, one of the elements, cadmium, is extremely toxic. So you can see it is always, comparing what do you want and what you can afford, and other consideration like something being extremely toxic. And finally, we have the flow batteries. Flow batteries are based for large-scale operations because they can attain 100% depth of discharge. What do we mean by that? The battery can discharge completely without going bad. Its lifetime can span over 30 years with minimal fire risk. You can see, if you are looking for a long-term, system, you can go for flow batteries. From their construction, they are very large and pretty expensive. They have low charge and low discharge rates. When we talk of low charge and low discharge rates, it means that it takes a long time for it to discharge completely, so it can serve you for a longer time. And when you are charging it, you don't need very serious um, high energy to charge the system, and it can discharge very slowly. In other words, an equivalent charge of a typical lithium ion can give you longer time when it is flow battery. Now, this choice of batteries have some factors affecting them. In most cases, the best choice is the lithium ion battery for home solar installation. We know the reasons. It does not emit gases, it occupies smaller space, and others. But if you are running on budget, you may consider the lead acid type. What do we mean by running on budget? Means that you have limited fund available to you for the purpose of acquiring the battery. If you have a enormous fund, the lithium ion will be better for you. If you are looking at the size of your pocket, you now may have to go for the lead acid battery. The lithium ion type can hold more energy in a small amount of space. Another key factor is whether to use AC or DC coupling. When we talk of AC coupled batteries, we are saying that they are just batteries you can add to an existing home installation. They are very easy for you to add them if you are already making use of a solar installation in your home. It may be difficult for you to add a DC coupled battery if you're already making use of an AC coupled battery. Reason being that they can be charged using the home's regular AC circuit or from already converted solar power from any kind of existing inverter. In other words, if you're already having an existing system and or you are going to operate a hybrid system where you'll be making use of the grid to sometimes charge your batteries, then the best thing is for you to use the AC coupled batteries. This energy conversion from your AC to another AC takes place 3 times in a typical AC coupled system, thereby introducing more losses. But in DC coupling, the batteries are charged directly from the solar panels and energy stored only gets converted to AC once. This tends to make DC coupled batteries more efficient since there is always 1 to 2% drop in efficiency for each energy conversion. So in the in the AC conversion coupling, you have 3 times conversion. So if each conversion gives 2% drop, it means by the time you do the 3 times, you already having 6% drop in efficiency. Whereas in your DC coupling, you have just 1 to 2. You can see now that the best coupling system will be for you to always make use of DC coupling. So if you are first time installer of solar system, the best thing is for you to go for DC coupling. But if you had already installed one before and you needed an upgrade, then you have to make use of the AC coupling. So we say DC coupling setup also means that it is cheaper to install alongside a new solar system because there is no need for a battery specific inverter. For new systems, please use DC coupling. The next thing we look at is the installation and wire sizes. Remember, the type of wire you use in your installation will also affect the efficiency because it will affect, losses due to heat if you are using the wrong wire gauge. So we say using the correct wire sizes ensure low loss of energy due to heat dissipation and to provide overheating. Of course, we know that overheating may lead to possible damage or even fire. So longer cable runs, that's when you use a lengthy cable, will result in higher voltage drop and may require large cable gauge. The table 1 seen below shows a chart giving the relationship between wire size and distance for connecting a typical 12-volt solar panels to the charge controller. In our previous lecture, we talked about, you know, um, 12 volts, 24 volts, and 48 volts solar system. And we say that depends on the battery rating you are using for your system. So we are going to look at a typical 12-volt system and see how we can select distance and cable to match. If you can't find the exact wire gauge that is suited for what you want to do, then you can make use of any of these two options. One, you can choose a higher wire gauge or select a distance longer than the actual distance. For instance, if you don't find a wire that is suitable for 10 feet distance, then you choose a gauge that is lower, but when you are computing from the table, you choose a longer distance to compensate for the loss in size of wire. So say the chart below shows wire distances for a 3% voltage drop or less. Of course, if you are working on your solar installation and you just record only 3% loss or drop in voltage, it is said to still be an acceptable margin. So what we are looking at now is a 12-volt system which can give about 3% voltage drop. Now, if you are using the 24-volt system, we just multiply what we are going to see by 2. If you are using a 48-volt system, you multiply by 4. For instance, let's look at the table. This is a chart. It's an already prepared chart, a standard, acceptable. So if you look at this chart, we say that the top row represents the wire gauge. That's where we have hash 12, 10, 8, 6, 4, 3, 2, 1. And the left column is the number of amps. Amps is the unit of current. The number of amps the solar panels are rated at. And the grid cells, the things inside, show the distance in feet between the solar panels and the charge controllers. So we'll come back to this table. Now, take for example, we have 3 solar panels, and each solar panel is rated at 6 amps. And these solar panels are mounted 30 feet from the charge controller. There. we need to choose the cable that will give us the best performance. What we will do is we go to that table. We are told 3 panels, each giving a current of 6 amps. So the total amps will be 6 times 3, which is 18. So in this table, we say that the left column is the ratings in amp. So 6 times 3 will give 18. If we go down, we see 4, 6, 8, 10, 12, 14, 16, 18. So you see, what we need is 18. So we go through the grid to see what cable we need. Remember, our example says 30 feet from the panels installed, 30 feet from the charge controller. So if we go through that 18, you see we don't have 30, we have 5.1, 8.1, 12.9, 20.4, 32.5. So you see that the closest thing we have is 32.5. So we follow it up because we are told that the top row represents the wire gauge. So if we follow that 32.5 up, it gives us 4. So we are going to make use of number 4 gauge, AWG. That is the rating of the wire we are going to use to get the best performance. The AWG stands for American Wire Gauge. So we say that it then means that we will be using or needing at least number 4 gauge wire, AWG, to move 16 amps 30 feet with a minimum voltage drop of 3% or less when we are making use of 12-volt system. We say if we are making use of 24-volt system, then we have to, use a longer or a bigger gauge so that 4 we multiply and use something like number 8 gauge. That is what we mean by saying that for 24 volts, we multiply the distance by 2. And for 48 volts, we also multiply the distance by 4. So the 24 and the 48 gauge also have their own tables, which will help you to just read out the values and get what you want. If you are using a 10 panel system and each panel is feeding 5 amps, it means that the total amp you have will be 5 times 10, which is 50 amps. So the table here does not contain that. So you can look for an extended table that can give up to 50 amps. Or you follow some other model calculations to get that. So now, if you're connecting the charge controller, after connecting the solar panels to the input terminals of the charge controller, you can use the same size of wire to connect the charge controller to the batteries, since this will always be, carrying the same current but of shorter distances. Because the longest distance will be from where the solar panels are, probably on top of the roof, to the enclosure where you are having your inverter, your charge controller, and your battery. So you get the size of wire that gets from the panels to your enclosure where you have the equipment. Then you can use the same battery gauge, wire gauge, to do the connection. But if it is possible for you, you use the next higher gauge. In this our case, since 4 is what we got by calculations, to be on the safer side, you can use um, size 5. So both the power inverter and the batteries require the largest wires in the system. During operation, the AC produced by the power inverter draws considerable current from the batteries. Not only are very large wires required, but they should not exceed 6 feet in length to reach the batteries. So what we are saying here is that no matter where you are keeping your battery, your inverters, and your solar controller and your charge controllers, make sure that the length is not more than 6 feet to reach the batteries. Warning, always use the largest size cable size possible. Like in our example, we say use number 5 AWG, American wire gauge. That is a gauge above what was computed. When you do that, you see that will be on the safer side. So an AC appliance drawing 10 amps, for instance, like a microwave, oven, or vacuum cleaner, will require 100 amps at 12 volts DC. When you pass 100 amps in a cable, that cable must be sizable enough, or else it will get heated up and may lead to fire outbreak. In most cases, when you hear of electric fire, the cable used is unable to withstand the current that is being drawn by the system. It heats up and that leads to fire. So you must guide against it by using a wire gauge that is bigger than the one computed. So we say that connecting to the solar batteries, the size of the cable will depend on the current allowable to flow through them and the distance the current will flow. We've said that you don't allow that to be more than 6 feet. So generally, typical values of between 10 to 15 American wire gauge standard size can handle the amperage required for any home without causing excessive voltage drop or overheating. Different voltage systems are variable, that is 12, 24, 48. Our computation was based on 12 volts. So if we are using the 24 volts, automatically our wire gauge will be 8, gauge number 8, and so on. Now, we know that in theory, solar system require low maintenance, but not actually so. So say solar systems are virtually maintenance free and will last for decades. Once installed, there are there are no recurring costs because it does not require you to add fuel anytime, provided you observe some key cautions. Now, observing some key cautions entails adhering to the correct battery that is needed for your system. We've seen the lead cell, the lithium-ion, the flow ion, and the cadmium nickel ion batteries. You must consider your system and know what is best for you. When you know what is best for you, it will help you to select the best. Then you must select the good and the best wire gauges to do your installation. Immediately you do all these things and do them correctly, you will notice that your solar system will serve you year after year after year for a very long time. That is only when the low maintenance we are talking about will come in. You may only need to, top water if you're using the um, lead acid battery that requires topping of water. You may require putting a vent if you are using a battery that emits gases. You, you know, um, require little or no maintenance, provided you adhere to all the things we have said. More especially what we said in our part two, that before you even start contemplating, you must first of all make sure that the building where you're going to install the solar system has very good and proper earthing. If you don't earth your house, the building very well, then spikes or electric arcs from lightning will always be affecting your inverters. So if you take the cautions the way they should be, then you will enjoy solar system that will last you for years. In our next lecture, we will quickly, itemize all these cautions you must take, and I will also present my thoughts on how best government, NGOs, and what you have can help to make sure that many people harness this clean energy using solar, which is environmental friendly. Thank you for listening.